All right, number 8 here for the standard normal curve, find the z-score that corresponds to the first quartile. Okay, so we're doing something different now. So earlier we were taking a z-score and then going to an area slash probability. That was earlier. Now we're going to it from an area slash probability to a z. Okay, so we're doing it backwards. So this first quartile, so what are we actually talking about? We're talking about looking at the distribution. First quartile is the first 25%. So we're talking about looking at this, and we're looking at this to be 25%. But we know that we have to then convert that into 0.25, right? So then we're going to go to Excel here. Now let's wipe all this out. So this time we're going to go in the inverse. So we're giving it the probability 0.25, probability or area. And then that's telling us the z-score of negative 0.67. So that's telling us here, and hence that was D. All right, assume the random variable x is normally distributed, mean 70, standard deviation 16. Compute the probability that x is less than 90. All right, so now we're using x values. We don't have the standard normal. We have a normal distribution. So we're going to go from x to z. All right, so that's z equals x minus mu over sigma. So we have x. So let me get a look at what we're ultimately looking for. X less than 90 when the mean is 70. So 70 would be in the middle. So 90 is going to be over there. So we are doing less than, so to the left. So we're going to take this 90 minus 70 over 16, and that is 1.25. So that is the z-score that we're going to use. So instead of 90, which we can't look up directly, or it's not as simple to look up directly, we're going to look up 1.25 and take the area to the left of that. So I'll go back here, equals norm. What do we say the value? 1.25, true. Okay. 0.8944. And there we go. All right. A similar one, except this time we're going to be using an x and looking for when it's greater than a value. So the only difference here is that when we're looking at this normal curve, so we have mu of 100 and we're looking at 112, so that would be a little on the other side. We want this area. So again, we can find the left by looking it over, looking it up, and then we want to calculate 1 minus that to get to the right. All right, so again, z, so the score we're looking at, 112 minus the 100 mean over sigma of 15. All right, that gives us 0.8. And we go back, look that up. So I'll just modify this here. All right, 0.788 0.281. And then I actually just want to do 1 minus that, 0.2119 really. So this was, let me get those values back up, 0.7881. All right, and this is then 0.2119. That's what we want there. All right, IQ scores, normally distributed, mean 100, standard deviation of 15, 120. What would the z-score? Oh, this is a simple z conversion here. We're just going to do x minus mu over sigma. So we're looking to talk about the score 120. So minus 100 over 15 as the standard deviation. And that is going to be 1.33. Note that's still a usual value, being within 2 standard deviations of the mean.